you've probably heard that Python is now available in Excel. If not, I have a separate video on it. Check it out later. Do you know what the most common reaction is right now? Great, but Python in Excel doesn't work on external data. Why the hell do I even need Python? Let's start with the external data problem. Let's say that you just received this beautiful CSV file from your HR manager, and they have a meeting in like 10 minutes where they have to report on the outcome of this data. So they have to come up with some suggestions. Now, thank God they have you on the team because you're the data guru, you know what to do. Now, I just want to make sure that you don't make the mistake that a lot of people are making when they work with external data and they want to use Python in Excel. So you see, the way people are bringing this data into Excel is to actually bring it into Excel. No, don't do that. There's no need to bring your data in Excel. I know that you're probably not doing a Control-A, Control-C, and then opening up Excel and doing it this way, and then cleaning it up. You might be using Power Query, which is the proper way of bringing data into Excel. So you might be going to Data, grabbing data from text CSV, selecting the file, so that's our survey results, and then clicking on Load to bring the data into Excel. You don't need to do that. In fact, the process is a lot cleaner and your files are going to be smaller if you don't do that. So I'm just going to close this because that's not the approach we're taking. Well, here is the better way. Go to Excel, Data, grab your CSV file, so import data from text CSV, find it, import. I know until now it looks identical to what we just saw before, but here is the main difference. We're not going to click on Load. Instead, we're going to click on this down arrow right beside the Load button and select Load To. And we're only going to create a connection to this file and OK this. This way, the data isn't directly loaded in your Excel file. Now, we are going to quickly take a look at this data. I'm going to go in Python mode, so equals py. To reference this connection, we're going to start with the XL function. Start with the quotes so that you get a list of all your external connections and all your tables. So here I just have one. That's our satisfaction survey. So I'm going to select it. The moment I Control-Enter this, actually, we can get a preview of our data in the data frame. Okay, so by just quickly looking at what we're dealing with, we have the employee names, we have their work hours, looks like it's per week. We have their meeting hours, their email response time, the stuff that IT can collect these days, employee satisfaction, sick days, years at the company, training hours, performance rating. So many columns with numbers. Now, to quickly get a preview of everything, I can use the .describe method on this. Now, let's just spell this using the shortcut keys. And here we get a preview of all our numeric columns. So work hours per week, the average seems to be 40.6 hours. The email response time in minutes, average is 30 minutes. I'm a lot slower than this. This information is good to have. It gives us a good overview of each column, and we can quickly see the count, the mean, the standard deviation, min, 25th percentile, and so on. But it's nothing earth-shattering for our HR manager to present. Because we're dealing with a lot of numeric columns, and some of these might be related, because there might be a relationship between email response time and meeting hours per week, or work hours and employee satisfaction. What we could do is, instead of .describe, do .corr to get the correlation between our numeric columns. Just to make it clear that we only want to include numeric columns, we're going to put numeric only equals true. That's it. Control-Enter this, and look at what we get. +1 means we have a perfect positive correlation, and -1 means we have a perfect negative correlation between our metrics. Now, obviously, a metric to itself is going to have a 1, but we're looking for other metrics that are close to 1 or -1. For example, here we have -0.7. So this means that the more meeting hours we have per week, the lower employee satisfaction becomes. Now, there is a lot of interesting insight here, but no one wants to read these numbers in a meeting. So what we're going to do is quickly create a visual from this. We're going to use the Python Seaborn library, and it's already initialized for us under SNS. The visual I'm going to use is the heat map. So let's just select that and put this result that we can see here inside the heat map function, and take a look at what happens when I press Control Enter. I get the visual returned in the cell. Now I'm just going to kick it out so we can see it better. This is a lot easier to read. So the darker colors represent a high negative correlation and the lighter ones a high positive correlation. So for example, here we have a lighter color. This means that the more training hours are completed, the higher the performance rating of the individual is, which is great, which makes sense. This one is what we saw before. The more meeting hours we have per week, the lower employee satisfaction becomes. Now, these are great insights that our HR manager can present at their next meeting. And the beautiful thing is that we don't even have to load the data in the file to create this visual. We're just connecting to external data. Now, of course, we know that the other managers are going to ask, but what is the correlation? So we want to add annotation to this. Let's quickly go ahead and add anot equals true. Control Enter this, and now we can see the correlation here as well. If you're having a good day, you could provide the HR manager with more data-backed recommendations that they can take to the meeting. So we could zoom in on one of these. So the one that really bothers me is the meeting hours per week and employee satisfaction. We definitely want to get them to reduce the meeting hours per week. So let's zoom in on that. Let's use the Seaborn linear model plot. And first we're going to go in Python mode, sns.lmplot this time. Now I haven't given my data frame a name, so I'm just going to reference it again. Now we have to define what we want on the X and the Y axis. So on the X axis, I want the meeting hours per week. So in quotes, we're going to type it in, meeting hours per week. Now for the Y axis, we want employee satisfaction 1 to 10. So they didn't hold back on the column names. Close the bracket and Control Enter this. Let's kick out our image. So right mouse click display plot over the cells. There is a definite relationship between the two. The more meeting hours we have, the lower employee satisfaction becomes. So if they ask, well, by how much should we reduce the meeting hours, or what's the optimal meeting hours per week? Well, let's say if we want to keep employee satisfaction at 9, the meeting hours would be somewhere between 4 to 6 hours per week. That's a concrete recommendation that they can make. Also, don't forget that you have a connection to the file. So if your source data changes, all you have to do is come here and refresh this, and everything is going to pull through. Now, your connection is found here under Queries and Connections. If you need to update something, if you need to change something, you can go to the Power Query editor and do it. So in case your data isn't clean and you need to clean it, there are lots of easy steps that you can do in Power Query, a lot easier than with Python. And if you want to dig deeper in Power Query, we have a course that has helped thousands of people save hours per week. And if you're excited about learning Python in Excel, we have a full course coming soon with lots of practical examples. I'm going to link both below. If you want, check it out later. By the way, if your data is in another Excel file, you can connect to it the same way, except you would choose Get Data from File, Excel Workbook. Select your file, click on Import, and then you can select the table or the sheet, whatever you need. And again, don't load it, but instead select Load To and only create a connection to it. Now you can use Python on that, right? So if I go to Python mode and type in Excel, I can see the connection here, select it, and Now you can do whatever you want on this data set. So that's how you can use Python in Excel and work with external data. I hope this also addresses the question or comment on why the heck do I even need to use Python? It opens up a lot of opportunities. Now we just did something simple, but there is a whole world of advanced data analysis that's now available to us. I hope you enjoyed this video. Let me know what you think in the comments, and I'm going to catch you in the next one.